Hello students, this is Miss Dalton. Today we're going to talk about relations and then we're going to talk about domain and range of different relations. So first off, we need to talk about the definition. A relation is a set of ordered pairs that can be written in 4 different ways. So the first way is just as a list of ordered pairs. The second way is as a table. The third way is what we call a mapping. And the fourth way is just to graph it. Alright, so let's look at an example. We're going to represent the relation that is shown in the coordinate plane as ordered pairs, then we're going to do a table, and then we're going to do a mapping. Okay, so first off we need to write these ordered pairs, and I'm just going to go from left to right. So if you look at this point right here, you always want to write the x value first. So if you go from the origin, you're going to go to the left, which is negative 1, 2, 3, 4, 5. So the x value is at negative 5, comma, the y value is up 1, so that's a positive 1. Okay, the second ordered pair is right here. You had to go to the left, which is negative 1, 2, 3. And then we went down 2, so that would be negative 2. This third ordered pair right here, you had to go to the left, negative 2. And you went down 1, 2, 3, 4, 5, so that's a negative 5. You always want to write the x value first and then the y value. Okay, then we have the one that's at the origin, which is just 0, 0. And then we went to the right 2 and up 2 to get to this point, so those are both positive 2, positive 2. And then this one right here, we had to go 1, 2, 3, 4 to the right. So it's a positive 4. And we went up 1, 2, 3, 4, 5, 6, so positive 6. And then this last point right here, we had to go over 1, 2, 3, 4, 5, so positive 5. And you had to go down 2, so that would be a negative 2. So this is the list of our ordered pairs. Now if we want to make a table, what we usually do is we'll just list these ordered pairs in table format. So the first ordered pair was at negative 5 on the x-axis, or in the x direction, and 1 in the y direction. Then we'll list the second one, negative 3, negative 2, and then negative 2, negative 5, 0, 0, 2, 2, 4, 6, and then we have 5, negative 2. Okay, then we have our mapping. Now with the mapping, what we generally do is we list our x values, we list them from least to greatest. So let's look at our x values in all these ordered pairs. So we have a negative 5, we have a negative 3, negative 2, 0, 2, 4, 5. Since I listed them in order from left to right, those are already in order from least to greatest. So we're going to put those values in the x oval. Now if I had any x values that repeated, you would only write it one time. In this one I don't have any that repeat, so I'm just going to write them all down. Negative 5, negative 3, negative 2, 0, 2, 4, and then last but not least 5. Okay, now let's look at our y values. We have a positive 1, we have a negative 2, we have a negative 5, 0, 2, 6, and negative 2. So we're going to write those from least to greatest. So if you look at all of those y values, the lowest y value is at negative 5. Okay, then the next value would come at negative 2, but notice we have 2 negative 2's, but we only write it down one time. Then we have a 1, a 0, a 2, and a 6, so the next one's going to be a 0, and then 1, and then 2, and then 6. Now after you've listed them from least to greatest, then now what you're going to do is you're going to connect the ones that go together. So negative 5 needs to go with positive 1, so I'm going to draw a line from negative 5 to positive 1. Negative 3 goes with negative 2, so that's just straight across. Negative 2 goes with negative 5, so that's up here. 0, 0, 2, 2, and then 4, 6, and then 5, negative 2. So that's going to come up here and match up with that one. Okay, this is considered a mapping, and it's just mapping an x value onto a y value. Okay, so let's look at a few more examples, or a few more definitions, I'm sorry. The domain is the set of all first coordinates in a relation. So that means that it is all of the x values when you look at ordered pairs. So going back to our first example, the domain would be, we're going to use these little curly parentheses called brackets. It would be negative 5, negative 3, negative 2, 0, 2, 4, and 5. And a lot of times people will even put before it, they'll put the capital letter D with a colon. Okay, so let's talk about range. Well, the range is the set of second coordinates. Which would be all of the y values. So if you go back to our previous example, the y values, so what a lot of people do is we'll put the R, the capital R with a colon, and then the curly parentheses. So the range would be all the y values, which were negative 5, negative 2, 0, 1, 2, and 6. Now notice in the domain and range, we will also list it in order from least to greatest, and we will also not list any numbers that repeat. Okay, a function. A function is a relation in which none of the first coordinates repeat. In other words, all of the x's are different. And I'm running out of room, so I'm just going to abbreviate that. Different. I'll put it down here. Okay, so let's look at example 2. Example 2 says state the domain and range, and then determine whether or not the relation is a function. Well, to do the domain and range, for domain you want to look at the first coordinates, which are your x coordinates, and so we're going to underline them. We've got a 1, negative 2, negative 1, 4, and 2. You want to list them in order from least to greatest, so we're going to put the little curly parenthesis. The least value, which would be the negative 2, and then we'd have negative 1, and then we'd have 1, then 2, and then 4. Notice that none of these x values repeat, therefore it is a function. And then now let's look at our y values. We have 9, 5, 6, -3, and 8. Let me move this over just a little bit so I have more room to write. Okay, so it looks like that the first, the least value, which would be the -3, then we would have a 5, then we would have 6, and then 8, and then 9. Okay. Okay, moving on to example 3. It says express the relations shown as ordered pairs. State the domain and range, and then determine if it is a function. So we're going to start by just listing the ordered pairs. So we have to see what matches up. So if you look at the 2 that matches up with -3, so our first ordered pair will be 2, -3. Second ordered pair goes from, we could do the 2 again, the 2 goes to 12. So if you notice that that 2 value repeats, so this is not going to be a function, so I could go ahead and circle that. The next ordered pair, 1, matches up with 5. Fourth ordered pair, 0, 0. And then last but not least, the -1 matches up with 5. So all you're doing is you're just seeing what match up. Okay? Well, the domain is going to be our x values, which we can get from this oval right here. They're already listed in, well, actually they're listed from greatest to least, so let's turn those around. So the least value is at -1, then 0, then 1, and then 2. Okay? The range would be your y values, which are over here. And going from least to greatest, it would be -3, 0, 5, and then 12. All right, we said it was not a function, and we need to explain that. Well, it's not a function because the 2 value repeats. So we can say that the 2 value repeats. You could also say that 2 ordered pairs have an x value of 2. That would be another way to explain it. All right, don't forget when you're done watching this video, fill out your WISC and submit it, and we will work on this tomorrow in class.